in your discussion, that's a bit better. Sorry, that was a really weird sentence. So once you've got your results, if you talk about it in your discussion, it's a bit more comprehensive as to where your information that you found fits in. But you can talk about any gaps in the introduction, because if the research you're doing is trying to fill a gap, then it's definitely something that you want to lay out to the reader so that from the beginning they understand why you've been doing this. And yeah, okay. So then thesis, yeah, it is. So this was my dissertation that I did for my BMed Sci at the end of third year, because we do it integrated in our course. Yeah, so introduce any measures. Yeah, review articles. So yeah, go down that rabbit hole, make notes on your article so you don't need to read the whole thing again. In terms of like talking about measures, so I talked to shall do it. So I talked about lactate and methemoglobin. Lactate's fairly common in medicine. Methemoglobin slightly less so, but it's worth explaining what each of these is, like what each of them is, what the evidence behind them being useful is, and why you're looking at them. So it's really important to define the things that you're going to be measuring as well, if you know them from the beginning, which you should. Another general point, define any abbreviations that you use before you start using them as an abbreviation. So, for example, where's VEGF first mentioned? VEGF, yeah, here. So, like, I've got vascular, like, all you need to do is just write vascular endothelial growth factor and then put in commas in brackets VEGF, and you can use VEGF for the rest of the time. Is it reasonable to do a rat study as a medical student? Very good point, actually. Yes, you can. And what I'm about to say applies for if you're quoting any like animal studies during your research, is you can definitely do it, but it's always worth acknowledging where your limitations are for a study. So in fact, any study, you need to acknowledge what the limitations are. And I'll kind of go on to that when I go on to my discussion. But for animal studies especially, it's worth having an idea and noting down in your paper that just that they don't have the best track record when it comes to actually translating their findings into a particular clinical treatment. So you can't go animal study directly to treatment. You need to sort of do some human steps in between. So yes, you can use them, but you just need to be a bit more on it about like saying what the limitations of it are. Because you don't want to say, oh, in rats we found this, and so we should definitely do whatever in humans, because that's not how it works. And you don't want to be conveying that in your research, because it's kind of misrepresentative. Sorry, was someone going to say something? No? Okay. Right, so any questions so far about anything while I scroll to methods? No, cool. Okay, so with methods, this is where things can get a little bit difficult. So the first thing is it's really tempting to give like a little summary at the beginning of your methods, because obviously that's what in your introduction, you've done a massive spiel about everything to do with this topic. And just to like make it really clear, it's really tempting to put in a little introduction kind of paragraph going, so our introduction has summed up this, and now we're going to go on to methods. Don't do that. So keep it as separate as you can. So methods should literally just be for methods. So for example, here I've said, in this study, relevant cases were defined as females, blah, 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 blah. Don't say something like, this clinical data analysis retrospectively looked at patients diagnosed with ovarian cancer. The primary aim was to assess, etc. Because you've already laid that out in your introduction. All you're doing is repeating yourself, and it's not really doing anyone any good. If anything, it's kind of muddying the waters as to, is this your method or not? So methods should literally just be like a list of everything you did from the beginning, so that someone else could repeat your experiment. And it should be a list without any results as well. So where I've said relevant cases were defined as females having undergone this surgery at City Hospital, the criteria for inclusion were, and then I've put the criteria down. You shouldn't after that put 53 people were identified, because that's not, that then belongs in your results. Your method should literally just be the steps you took to get there, rather than what you actually found. Yeah, and then it's also, so that's the other thing as well. It's really tempting to put in results in some form, because especially if it's a really small thing like the number of participants. I'm not recording it. I don't know. There was a bot to record it, if anyone knows how to work it. But I will. Oh, okay, perfect. So yeah, so in terms of putting any results in your methods, stay away from it. Like there should basically be no numbers in there unless it's something like the number of databases you used or something like that. So yeah. Oh, is that a general thing? Can other people see my screen or?
I can.
Okay, it might just be you. Then oh no, you can't. I'll try shutting it and starting again. Any better? Okay, solid. Yeah. So, what was that? Sorry.
This is the first time I've been able to see. I thought it was just my Wi-Fi.
Oh, okay. Well, if anyone can't see, then just let me know and I'll stop and start again. So yeah, with methods, keep results out of it by like all means, because again, all you're doing is like muddying the waters between is this your methods, is this your results? So it literally just should be a list of everything you did. What you've looked at. And then when it comes to actually talking, so all I've done here is I've said, look, this is how we picked our patients, this is how I picked our cohort, which is usually the first thing that you say. Then say, like, this is where we collected our data from. And then the data we collected was this. And then after that, you can start talking about how you actually analyze your data. So this isn't weird spacing. I've just taken out the initials of the other people involved. So for privacy stuff. So in terms of data analysis, again, you want to do it in as logical, a step-by-step fashion as you can. So I said, look, the first thing we did was to anonymize the data. Second thing we did was then test for normality. And then you state which tests you use. So I use these weirdly named tests. And then you want to go as specific as even saying, if you've got categorical data, so things that are like yes or no, as opposed to continuous data, which is on a scale, how did you enter that in? Did you enter it in as binary values? So like 1 or 0? Did you enter it in as like yes or no? Do that. And then say, after you've done this first step of analysis of like calculating normality, what test did you then do to look at statistical significance? So don't worry too much about statistics if like that's not something you know a lot about. Just sort of the main point is be as step by step and as methodical and detailed as you can. Another thing, actually, a good point here is talk about what happens with data samples that weren't there. So especially if you're looking through a database where it's perfectly valid for things to have gone walkabout and you're just missing samples left, right, and center, that's absolutely fine. Like there's nothing wrong with that. But what you need to say is what you did in that situation, because there's different ways of dealing with it. So some studies will just omit it completely, which is what we did. But other studies will put in a mean value based off all the other results and use that. So you need to say what you've done with any missing data as well. And then when it comes to talking about data analysis in your method, there's 3 main things that you need to identify and define. And if you don't do these, it just doesn't look great at all. And it means that you can't really make any assumptions or you can't really take anything from your study because you haven't done these 3 statistical definitions. So first thing you need to do is you need to identify your test for a p-value, so statistical significance, and identify what your cutoff for that is. So if anyone knows anything about like science stats, your p-value is basically just how likely is it that your result was down to chance. And there's different sort of levels that you can use to define it. So you can say at a level of less than 0.05, which means that there's like a 95% chance that your findings weren't just like random. Yeah, 0.05 is the best. And that's what you'll see most papers sort of using. Some papers will really go in down as detail and use like 0.01, but far and beyond, like most of them will be using 0.05. Now, that level that you define is called the kind of alpha value. So that's the probability of a type 1 error, which is basically, have we said this is true when it's not? The second type of error is called type 2, and that's the opposite of that. So that's saying, have we said something isn't true when it is? So that's like saying that a drug had no effect when in fact it did have a massive effect. So the way you kind of deal with that is by defining this thing called a beta value. And this is getting a little bit more into stats now, so like literally don't worry if this doesn't make sense. But just briefly, what it is it's basically just saying how likely is it that you got a false negative. And it's related to this thing called power of a study. And what the power is related to is how big is your sample size, basically. So if you've got a really big sample size, the likelihood of you being able to detect a false negative is a lot higher than if you've got a small sample size like we did. So in this data analysis part, what you need to say is the p-value or the alpha was set at 0.5. And then because ours was a pilot study, which is like an initial study into an area, we didn't do any power calculations because there's absolutely no point, because nothing that we find is going to be like generalized to practice anywhere, because it's a really small study, it's retrospective, nothing about it means that it's amazing like research. What it means is it gives us preliminary data to go on and investigate this stuff further. And those ones will do like their power analysis and things like that. And they might also change their alpha value. So if there's any scope for these sort of values changing as well, it's always worth writing that. So we said like the alpha value is subject to a degree of change for power calculations. Basically meaning, look, we know our results aren't going to be anything like that you can take and generalize very far. So we've just set this because it's like the standard amount. It's a standard value used, but if it needs to be changed in the future, go for it, change it. Like, we're not saying that this is a hard and fast rule with this topic area. Any questions about that? Because I assume that's going to be the bit that has questions, if any, come up. No? Okay. Yeah, don't worry about stats too much. It's something like, if you come around to doing it, it's something that you will then have to sort of struggle through then, and some of it is an absolute nightmare to do. But just kind of Google is your friend there, and even better if you've got anyone at your university that's like good at stats, go and get them, like go and ask them for help. So then another thing that's really key is reference all of the software you used, even if it's stuff that you think like won't have a reference. So I used Python for some of my data analysis, and I was like, oh, I need to reference that, and in fact it has a specific way to reference it. So basically absolutely everything needs to be referenced. And then finally, a really, really important part that is quite easy to just skip over and miss is you need a paragraph in here talking about how you're going to present your data in the results. Because if we scroll down to results, all it ends up being is like a whole load of numbers everywhere. And so you don't want to make it even more difficult to read in terms of having to explain how you've presented results each time. So if in the methods you just put in a general like, this is how I'm intending on presenting my results, then that means that the person knows going into the results section what kind of thing that they are. Yes, SPSS will do it for you. SPSS is great. Yeah, so when it comes to saying how you're going to present your data, that's really important. So what I've said was we did a normality test, and then we did a t-test if the data was normally distributed, and like this different test, the Mann-Whitney test, if it wasn't normally distributed. And the reason for that is the Mann-Whitney and t-test have different they have different requirements for them to be like valid in terms of how normal your data. But go into results, we don't need to say, with this result, I determine normality by doing this test, and then I use the Mann-Whitney test to do this. It just means that you can literally just state your results because they'll already know how you got there. So it saves you a lot of words. And then talking about how you're displaying it is just this bit. So saying all normally distributed data is displayed like that, and non-normally distributed data will be displayed like this. And again, it means you don't need to explain it every single time you put data down. So it just gives it a nice sort of easy way for them to see it. Any other questions?
Yeah. On my course, we haven't used SPSS yet. We do it in year 2. So we're doing like independent t-tests, Mann-Whitney use, all of that, and we're doing it by hand. But just so I can prepare for it, when you do a calculation in SPSS, will it flag up to you in some way if it's not normally distributed, or do you have to work that out separately?
So on SPSS, what you need to do is you need to do one of the normality tests, so either a Kolmogorov-Smirnov test or a Shapiro-Wilks test, to determine what's normal, what's not, and then from there you can put in you can put it into SPSS. So you kind of need to do that step. I don't know if maybe there is a way to tell you whether it's normally distributed or not. I just did it like separately just to double check. But as far as I'm aware, you just kind of need to do it separately and just make a note. This is normal. This is not. And then depending on those results, you can put it into either a t-test or a Mann-Whitney test.
Okay, thanks.
No worries. I wish you the best of luck with doing that by hand because they're an absolute nightmare. Like I hated doing it with SPSS, let alone by hand. Okay, so results. Results have they can very easily become overly complicated when you're writing them down. So sometimes people will try and like start analyzing their result in the results section. Leave that for the discussion. All you're trying to do is just state everything you found, kind of in a list, but not explicitly in a list. So, and then the other thing is make sure that you address everything in the methods. So, like, if in the methods I'd put in, where's it gone? If I'd put in something like lactate measurements, and then I hadn't talked about lactate in my results, you may as well take it out of your methods because it's not relevant. Because they'll either be saying why, like, where are these results, or if you haven't looked at it, then why have you bothered putting it in? So just make sure it's that internal coherence, saying that if you've got something in your methods that you've looked at, that you've stated what you found in your results, or you haven't just started pulling results out of nowhere kind of thing. It needs to follow through from the beginning. So when it comes to results, you can determine how you want to structure it yourself. Like for mine, it just turned out to be quite a nice way to talk about the demographics because that's the first thing I talked about in my results. So actually, follow it through in the order that you talked about it in your results. So the first thing I did was talk about selection of patients. So that's the first thing I talked about in my results. And then I talked about all of this stuff in terms of like what I was actually looking at, and that can follow. So yeah, try and follow through in your method as much as you can. Another way that you can do it, and this is actually the way that I ended up doing it, was in terms of your primary aims and secondary aims. So I had one section, all of the data analysis I did for my primary aims, so that if someone just was really interested in my primary aims, not the secondary aims, it would be really easy for them to just come in and look at that section alone, rather than having to dig through and find it all themselves. Yeah, so do that. In terms of wording as well, be really careful. The one word you want to be super, super careful about using is significant, because in research papers, that is like an absolutely massive thing. When you say something significant, what everyone will assume you mean is it's statistically significant in terms of you've done the normality test, you've done the p-value test, and that has come out as something less than 0.05, and so it's statistically significant. If you just say, oh, this is a significant result because it was the opposite of what we thought it was, but you haven't done all those tests, then you're not presenting your data properly. So be really careful about using that word. If you can, well, not actually if you can, do not use that word unless you've done a test, essentially. As well, tables and figures as well. It's a really good practice to get into the habit of using tables and figures to illustrate the text rather than replacing it. So if you've got something on a figure that you think is really important, but you haven't talked about it in the text, then something's gone wrong. Like, you need to have talked about it in the text, and the figure should just be there to describe it. And then when it comes to actually talking about or doing the little bit underneath the figure, write it in a way that means that you can it can be looked at on its own. So it's not always possible, but it should be most of the time, and that's sort of what you should aim for. So, for example, for this pie chart, I could have just said pie chart looking at differences in therapy for ovarian cancer, but that wouldn't have been particularly helpful. You would have had to go back and read all the text. Whereas if you put in pie chart visualizing this from this place, and you put in your n value, which is the number of participants you've got in there, and you do it in a really pretend it's like a GCSE describe question, and just really state the obvious about what you're showing. That means that all the lazy people reading it, and everyone reading these papers is super lazy, no one wants to sit there highlighting text all day, can just flick through, look at the figures, and still get the gist of what your results are. So yeah, try and treat them like they're standalone kind of objects. In terms of structure, generally with results, I know I'm looping back a bit here, but I feel like it's such an important point. Just have good structure. So don't just say analysis of primary, where is it? Next page. Don't just say analysis of primary aims and then have 4 pages of just words without having subsections. Explicitly say what you're going to be looking at in that section. And then that not only means that it's nice and easy to see how your results are split up, but it means that you can have these nice, that's not, okay. It also means you can have these nice short paragraphs, which is what you want. You don't want a whole page of this, what I've got on the screen right now, because it's just a nightmare to look at. So what you want is to be able to have really nice short paragraphs that someone could look at and then go, oh, okay, and here's a figure corresponding to that. And actually, the way that you lay this out is, again, it's a personal thing. It depends however you want to do it. The way I did it was so that, because you'll be noticing I've killed a mini rainforest somewhere by not using a whole page. But what it meant was that when they printed this off, what they'd have was this bit of writing on the left-hand side and the corresponding graphs on the right-hand side. And I've kind of stuck to that throughout my results section. And again, that's just an extra thing that makes it a lot better for the person reading it in terms of seeing reading what you're talking about and then seeing the corresponding figures. Just makes for a nicer experience, which, especially if it's a dissertation, you kind of want, because that person's then marking you on it at the end of it. Yeah, and what else? Oh, make sure everything has units as well. Even things that you don't normally talk about as having units. So for me, it was BMI up here. I didn't even clock that had units until my supervisor went, "Where's the units for this?" So any value you use whatsoever, there will be units for it. Use them, put them in. And along those lines, always put in give the n value. If you don't give the n value, it's kind of like what the media do when they say, say they said eating bacon every day for breakfast means you have a 10% increased chance of getting cancer. What they don't tell you is the cohort size for that study was 5. And so that means that the actual increase is like 0.5 of a person. So if you don't give these n values, you're not explicitly misrepresenting your data, but it could be construed as that, and it's not really something that you want people accusing you of. So just put the n values in wherever you can, including diagrams if you can, because again, it just adds to that whole standalone idea when you're captioning them. And then again, going off that kind of, you don't want to put any opinions into your results. Be really careful when you use adjectives to describe data. So if I said somewhere about I don't know, say I'm talking about this this type of surgery, and I said, oh, this shows that it's a more serious surgery. That's not like, there's scope for that to be sort of perceived as being an opinion, as opposed to if you said something like, oh, it's an aggressive surgery, because that's technically true. It's a very grey area, but try to keep opinions out of it as much as you can. And then, figures, actually, while we're looking at figures, make sure it's a really easy place. So if this is being marked, really easy place to lose marks. If it's not being marked, it just looks a little bit unprofessional if you don't do it. But make sure that your formatting is on point. My formatting was in fact terrible up here. So like that, I should have put spaces in between. But it's just small things like make sure that you've got units where you need them, make sure that every graph has a title, stuff like that, like very simple stuff. Make sure like capitalization's okay. Very simple stuff, but again, if you get picked up on it, it just doesn't look great. Luckily I didn't get picked up on that. So yeah, try and keep your formatting generally like in a good way. Be aware, sort of going back to SPSS, actually, it spouts out a whole load of stuff that isn't always relevant. So there was one example that I had. Where has it gone? Okay, here. So, because I specifically remember thinking this is like the most useless thing. When I was looking at these numbers here, what SPSS was giving me was it was giving me results to like 0.1 of a milliliter. When you're talking about a range of 1.5 liters to 11 liters, there's no there's no point in having milliliter, like 0.1 of a milliliter as a decimal. So just try and like take it into account in terms of if it's giving you decimal places all over the place where they're not necessarily needed, just do some rounding. Especially if it's like a range where it's not a whole, like it's not it doesn't make a huge difference. So yeah, beware of random stuff stats programs throw out. What else can we talk about? So have I got any p-values? So p-values, always put them in where you've calculated them. Even if it's not relevant, that doesn't mean you don't need to put your p-value in. With p-values, don't use leading decimal places. So don't put like So don't put like 0.75, put 0.75. Especially if you're a medic, you'll get absolutely crucified if you do this, because if you just have a leading decimal point like this, it can cause like some next level screw ups in terms of dosing. Because like if you're supposed to give someone 0.75 grams and you suddenly give them 75 grams, you've like increased their dosage like 100-fold. So leading decimal places are very bad. Don't use them. But talking about p-values, also be very aware that you can find differences that aren't statistically significant. That doesn't mean they're not relevant. So a lot of people will automatically go, oh, this isn't statistically significant, it's not relevant to my study at all. That's not true, because sometimes you'll find that something that you really thought was going to have a statistical significance doesn't. And then the next question is, well, why not? And then that can lead you to a different study. So never leave anything out if it's not statistically significant and you've tested it, because even if you don't see it, someone else reading your paper might.
Yes, please.
That's something that is definitely sort of worth remembering, is don't just omit things. That was interesting. Don't omit things just because they're not significant or statistically significant. speaking on from that, if you're doing this on like a medically based paper, statistical significance doesn't always equate to what's called clinical significance. So statistical significance is something you do with a stats test. Clinical significance is what you decide as the person doing the research is, are these results actually relevant to clinical practice or not? Can they sort of go over, are they relevant to changing how we do things? And they don't always relate. So just because something's not statistically significant doesn't mean it's not clinically significant. It still can be, and vice versa. I was helping to proofread someone's actually, and they started talking about a null hypothesis in their results, which is absolutely fine, but make sure you define what it is. So don't just say, oh, this, so like the change in hemoglobin, like the test we did, backed up the null hypothesis. You can't just say that and then leave it at that. You need to define what your null hypothesis is. Personally, I'm not a huge fan of just like of using null hypothesis because it's a little bit like just all the null hypothesis is saying we don't expect there to be a change. So just say that, like there's no point skirting around the fact, just say it in real terms. We don't expect to find a difference kind of thing. Yeah. And then QQ plot. This is a good example of when you might end up using some random stats test that no one else ever has like used, that isn't regularly used. So like pie charts, box and whisker plots, histograms, they're all fairly standard things that are used. This thing a little bit more out there in terms of a test of normality, but keep it in mind use the test is, because if it's not, then you might need to go to town a bit more on explaining what it's showing. So for this one, I had to pretty much do a little paragraph underneath saying this is what this test shows, because anyone that wasn't like an ICU doctor or a statistician just had like they didn't use it that much, and so it's something that you need to explain a bit more, because the last thing you want to do is in your results start confusing your reader, especially if they've actually taken the time to get to your results, because a lot of people just look at your conclusions and then let that be it. And then summary tables, I think, is probably the last point to make. So summary tables are good, especially ones where you talk about p-values and you identify the things that are statistically significant, and you can put in like a nice overview of everything you found, or like especially not so much everything you found, but the things relevant to your study that you found. And it just means as they get to the end of the results, again, you've thrown all these numbers and charts at them, they can get a hold of the important things going on to the discussion. So yeah, overarching summary tables good. Any questions about anything so far? No? Okay. So then discussion. So going back to the point about like how or about putting the significance or giving the reader the significant stuff first. Like, it's good general life advice, but do that in your discussion as well. So say what your key findings were. Don't go into them in like too much detail just there, but just have an overarching paragraph saying, look, here's a summary of the key things that we found. And then you can subsection that out and talk about each one specifically. So I said, like, here's like what we found for crystalloid fluid. And then in your discussion, it's all about taking what you found, comparing it to what's been found already, and like saying, how is this relevant to like practice at the moment? How is it relevant to what research is out there at the moment? And that's sort of something you should be aiming to do in every point of your discussion. So, for example, here, I kind of talked about what our study found, and then I compared it to what other studies, like previous studies, had found. And then just at the end of that, as like a nice linking sentence, you can say, as a result of comparing these two, we can say that this is clinically significant, or this isn't clinically significant, or, you know, whatever it is you're looking at. But again, it just rounds everything off quite nicely if you compare it to what's out there already. Probably worth, actually, did I talk about it? No, but then again, I didn't need to. So ethics. If your study is something that needed ethical approval, please talk about it. Like a lot of these things will need you to submit the ethics form along with the study anyway. But just say what ethics approval you needed. especially because if someone then tries to copy it and doesn't know they need ethics approval, then that might kind of screw them over a bit. But talk about it, even if you don't need specific ethics approval actually, but just that you needed clearance to access data, then that's worth talking about as well. But yeah, don't just completely leave ethics out, because it is quite an important part, especially if you're doing things like animal studies, like human studies, stuff like that. I've talked about clinical significance. That is an important thing is to stay within the remit of your study as well. So if you've got a pilot study, which is what ours was, don't then go making like definitive claims left, right, and centre that you've suddenly solved this massive problem, because at the end of it, like, a pilot study is just there to like provide some data to influence further like more comprehensive studies. So know what the extent of your results are, in so much as like how far they can be generalized, rather than going absolutely mental saying, this is what we found, is absolutely amazing, blah blah blah. This is a point of personal like opinion, but I think it's like a decent idea to try and keep any results or any graphs or tables out of your discussion if you can. And when I say out of your discussion, I mean like in line. Just because you're trying to compare what you found, your results, and you've already got like figures for that, to what's previously been put out there. If you do need to put anything in as like a summary of what you're saying in your discussion, that's absolutely fine. But I'd say put it in an appendix, because the appendix is there to have supplementary material. That's not an essential part of the text itself, but is like helpful in giving you a more comprehensive like overall understanding of either the research problem or the information. And so like graphs demonstrating what you've got in, or tables demonstrating what you've got in your discussion, kind of fits that, in terms of it's not a hugely relevant in terms of your understanding, because that's why the text is there, but it's just a nice summary. And so like I did that. I've got a table here, and it's nothing that I haven't said in my discussion, but it's just an easier way to look at it. And so, because it's not particularly relevant to understanding, I've just taken it out and put it in the appendix. So do that, and then talk about your limitations as well. So again, this kind of goes back to the point I made earlier, is that every study is going to have limitations. Like, no one's going to have the perfect study. So talk about them, because that it's not like admitting weakness, saying your study has limitations. It just means that it means that you and your reader will then be aware of how far these results can be taken, and it gives whoever's working on it next, be it you or someone else, it helps them make a more comprehensive study. So yeah, talk about limitations is an absolutely huge point. And then alongside that, actually, confounding factors is an important point. It kind of comes under limitations, but it's probably a bit more to do with study design rather than the limitations of the study itself. So if you have any, talk about them. So confounding factors are other things that can affect your results that you haven't necessarily taken into account. So yeah, and then talk about future studies. So give those people reading your paper an idea of what to go and do next, and like what to learn from yours. So a good idea is to split this like here into short-term and long-term studies. And again, that just means that anyone reading it will be able to actually take something away if they want to go and improve on your work. And then conclusion. So just try and summarize all of your results in your discussion, anything that you think is important for the reader to take away, into a nice couple of paragraphs. And again, if there's anything that you thought you'd find but you didn't, put that in there, because that might be something that they want to consider as they're going on to design their own study. Like, a lot of people are going to be really lazy reading studies, and I'm sure like if any of you read studies, you will have done this before, which is you go in, you read the abstract, you maybe read a bit of the introduction if you're not sure about something, but then you just jump straight ahead and go to the conclusion. So it's really important to make sure your conclusion's somewhat comprehensive. which then leads us back to the abstract. So abstracts are like notoriously difficult to write, because you're just trying to keep any of the extra fluff out of it. You're basically trying to give someone a one-page, like 200, 250 word summary of what is otherwise like a 60-page paper, which can be difficult. So when I was doing it, I found a good way to go about it was to like pretend that you're trying to explain your study in terms of background, aim, method, results, and conclusions to someone else that's never heard of it before. And you're trying to do it as quickly or as succinctly as possible and put that down on paper. And then once you've got that down on paper, you can work at cutting bits out. Because that's essentially what you're trying to do. You're trying to give this to someone that's never read it before, hasn't actually read your paper, but still wants to see what the main takeaways are. But it is a notoriously difficult thing to actually get right. So you'll probably need to do quite a few drafts of it. Yeah, that's about it, I think. Do anyone have any questions or anything? Yeah, don't worry. Especially like that stuff, don't try and don't worry too much. The main takeaways from it are, if you're going to go about writing one of these papers, make sure you've identified the hypothesis, make sure you know what your question that you're answering or that you're asking is. Next step is writing the introduction. Just do it in a way that someone who's never seen this stuff before can read it and then get a very good idea of the relevant background to understand what's going on. Methods, lay it out as clearly as you can, and don't put any results in there. With the results, just try and list out the results. Don't do any analysis in there. When I say analysis, in terms of discussing the implications of it, and then leave that all to the discussion, or the main 5 points. So, and in terms of literature review, no, I did not, because that's so it's a literature reviews, depending on how you're doing it, have very specific criteria. So a systematic review will have a specific set of steps that you need to do in terms of making it a valid systematic review. And with those, it's a lot more important to make sure that you're what databases you're searching, you include what search terms you used. Normally there's systematic reviews will have a flowchart showing how many studies they found with one search, and then how many they excluded depending on their criteria, and then how many they had in another search, and how many excluded, etc. In terms of structuring it, though, your structure will be very similar. So you will have an introduction about the topic. Your method will be a lot more about, to be fair, it will be somewhat similar in terms of structure. So you will have, instead of selection of patients, you'll have selection of or search criteria used, and then data collection, it will be what search engines you used, stuff like that. And then in terms of analysis, again, it will be how you analyze the papers that you found. But I haven't done a literature review, so but there are other. Don't worry, there are other literature reviews. Don't worry too much on me. So you can get what's it called? You can do a literature review that isn't as sort of structural and stringent as a systematic review. I forgot what it's called. I think it's a narrative review. So don't worry too much. Because if it's a systematic review as well, the unis and the people giving it to you are usually very good at making sure that you're aware of what the structure is. They won't just say, here's a systematic review, go do it, if you've never done anything like that before. So yeah, any other questions?
Can you ask anything about writing here?
As in,
Yeah,
so
just
as in
general.
you can, I can try and answer.
Yeah, okay. Do you know what reverse pyramid writing is?
Reverse pyramid writing.
Yeah.
I don't. Does anyone else? Feel free to hop in.
Yeah, my teacher taught me to use it more in my
I
essay.
can give it a Google. It might be one of those things actually that I've used. I just don't know what that's what it is. Reverse
I
pyramid
think it's
writing.
going from general topic to specific topic, right?
Yeah, it is. So actually, this said, that's journalistic writing. Yeah. So actually, that is something that's been done here, which is in terms of. So if we look at the contents, so you start off with an overview, and then you talk about a general so you start off with, let's go to that. Okay, so like here for vascular endothelial growth factor. So from a quick Google, the reverse pyramid thing looks like you just start off with like the general knowledge, and then you drill down into the specifics. So for example, here you talk about it's like here's the structure of what these specific hormones are, and then here's what they do, and you get more and more specific as you go down into it.
Yeah. So
Is what it looks like.
A bit of a summary in the beginning about how, what, where. Like
Yeah,
this,
exactly.
And then just build around it with more evidence and claims.
Yeah, perfect. So that someone could read that first paragraph, still have a good idea of like what you're generally talking about, and then drill down into it further and further.
Yeah, perfect. Thank you.
No worries. So crafting survey interviews. Oh god, that'd be going back to like A-level psychology. No, because I don't remember any of my my A-level psychology. So I'm sorry, Johnny, I cannot help you there. But yeah, if nothing else, let me just think. Did I have anything else? I did have some like vague notes to make sure I'd covered everything. Actually, this is a small point, but try and keep your if you're writing numbers in your introduction, as long as they're small numbers, like try and keep them in text as opposed to like numeric numbers. So, for example, if you're going to say like 7 in your introduction or your methods, say the word 7 as opposed to the number, and then leave all the numbers to your results. And again, it just looks a bit more like consistent. Oh, Johnny's our little scribe. Love it. That's okay. I'll let you off. Intro, general comparison results, JavaScript method. So that mainly came from, so if I go down to my discussion, if you've written the introduction, you will have a very good idea of what the previous literature says anyway. And because you will go into your research for your introduction, knowing what your hypothesis is, knowing what it is, what the question is that you're asking, then your reading around the subject that you've already done will be somewhat directed towards this towards your research questions anyway. And so when you look at your discussion, you'll be able to say, where is it? So, for example, okay, let's go to fluid. So some of my reading that I did said that when you're giving fluid to these people, that you should try and do it in a way where you don't like give them absolutely loads at once. You should do it in a restrictive way. But what we found was that it might actually be better just giving them a bit more, like giving them loads. So it wasn't something that I expressly like. Well, to be fair, actually, it was. So with each of my results, what I did was I took the result, and again, having like a nice signposted, really easy way of like really well laid out results helps you in doing this. But just go to that results section, so like fluid volume, and then go back to your introduction, look at what you wrote about it there, have a reread over any papers that you looked at there, and see what they say, and then take your result. Like if you need to, just write them down on a piece of paper with a line in between them and say, this is what I found, this is what they found, how do they compare? And then what you can do is you can go into like saying their results are good because their study was structured like this, but there's some limitations to their study, whereas our study didn't have those limitations, so maybe we're more correct. But it's all about making those comparisons into, like, you know, how, like, they've given us this data, but how relevant is it really compared to what our data is saying? And in terms of sourcing research for the intro, yeah, I think a good way, so doing a decent PubMed search is always a good start. So stick your keywords in, see what comes out. I think a decent way of going about it as well would be to find a few review articles, because review articles will have looked at all the literature for you and have referenced it. So as you go through that review article, not only will you be building up your own knowledge, but you will have a list of like good papers around the subject that you can then go and look into. So yeah, like, absolutely love review articles. They are a godsend when you're doing stuff like this, especially if you're doing stuff on really like niche things, and it can help. And so like start off with that, and then as you're going through, just go down that little reference rabbit hole and look up the references that you think are interesting and relevant, and you'll probably find that you get a lot of information that way. No worries. Any other questions? No? Cool. Right, I'll leave that there then. Thank you for coming, everyone. Remember to donate. The link's up there somewhere, but I'll repost it. No, it's not. It's in the study streams chat, like bit at the top though. So yeah, definitely go donate there. And I am doing a note-taking thing tomorrow at some point. What times it's supposed to be? It's down as non-Oxbridge medical stuff, but we've changed it. So it's at 3 p.m. So yeah, if anyone wants any advice on like note-taking or anything like that, come along. And thank you for posting that. Yeah, and I will see you there. Cool. Bye.
Thank you.
No worries.